Let's see here. Good morning, boys and girls. Welcome back. It's Thursday. I hope you enjoyed the little bit of variety in the assignments this week. Today we're going to get started with something new. I think you probably saw in your classroom up at the top now, we're going to work on Module 14 scatter plots. So we're going to start analyzing. We're going to look at and interpret bivariate data. And that sounds tricky and complicated, but it's not. Bi is two, like a bicycle or a bivalve, a clam or a mollusk, a two-sided shelled creature or a two-wheeled cycle. Two variables, bivariate data. Okay, so we're looking at that x and y axis, and you're clicking on this thing right here that says classwork homework, and you went in there and you opened up this here Google slideshow, right? Module 14 scatter plots, and then you went back to the classroom and you opened up this copy of scatter plot vocabulary, because you need all the stuff that I put in there all the time. And then you go back and you read the directions and you see what it says, and it says April 30th, positive and negative correlation of scatter plots. Watch the short video explaining the assignment and the vocabulary for this concept. Open the Google Doc and follow the instructions to complete the assignment using the Google slideshow. Mark as done. Okay, so we've opened the copy of the scatter plot. It's right here. Okay, at the top it has the date. It says scatter plot vocabulary. This stuff is really important for us to understand this concept, and it's going to be really important as you move on through high school and college level courses when you're in statistics class. Okay, this is statistics. Statistics 090, like the baseline, the foundation. It says define each term and provide an example or explanation of the definition. Okay, so the first term is a scatter plot. We want a definition and we want an example, and then there's data and cluster and correlation and line of best fit. So 5 words that you're going to define and then give an example or explain. Okay, explain what it means. So back over here it said use the Google slideshow. So that's right here. So when I go in here, I start to click through these slides. Right, this first slide, that's the standard. That's the 8th grade standard. This is what we're supposed to know. We're supposed to construct and interpret scatter plots for bivariate measurement data to investigate patterns of association between two quantities, describe patterns such as clustering, outliers, positive or negative association or correlation. Those are the same thing. Linear association and nonlinear association. Okay, these are all the things that we're going to talk about as I click through these scatter plots and data, and you can see the x and y axis on that graph down there, right? And clusters, you can see there's a group over here. We're going to explain clusters and outliers and correlation, positive and negative and no correlation, and line of best fit. Okay, this is our vocabulary. These are the first 5 slides we're going to look at today. Before that, these are the IXLs that we're going to practice with. Okay, if you want to watch some videos about constructing a scatter plot, all of these links here. Okay, scatter plot basic example. These are Khan Academy videos. Sal Khan does a really good job. They might not all be him, but there are other good explanations of all these concepts. Okay, so today what I want you to do, you've got your scatter plot vocabulary open on one side, and you've got your Google slideshow open on the other side. And you know, the first one, it says scatter plot. Okay, now I've already kind of, let's see here. Let's see what I can do. I've already gotten a little bit of a start here. Okay, so basically, I filled in the definition of a scatter plot and data, and then I gave some explanations or examples in my words. Okay, and that basically came from here, and I put it in my words. If you want to take the definition, right from the top where it says a graph of plotted points that show the relationship between two sets of data, that's okay. But then where it says example explanation, I want an explanation of what that means or an example. And so I'm going to show you kind of what I did here for these first two. So what I did, all right, let me see here, see if I can. See if I can do something here. I'm going to go like this. I'm going to make that bigger. All right. And I'm going to go to view. I'm going to go full screen here. All right. So you're going to put your name right there at the top of the page. You're going to define each term, provide an example or explanation for scatter plot. We said it's a graph of plotted points that show the relationship between two sets of data. Okay, an example or an explanation. If you look at the value of cars and their age, you could plot each point on a coordinate plane to see how the two are related. So that's an example. And then it says a scatter plot lets you visualize how measurable variables are related by collecting data points on a coordinate plane. Okay, so those are examples and explanations. And I'm going to make this a little bit smaller again. I'm going to go back here and I'm going to show you. If you scroll through this a little bit, okay, as you scroll through here, you can kind of see some of these other concepts here, okay, and explanations of these different things, and so you can get a little better idea. Maybe hours of video games played to grade point average. You can see that's an example of a negative correlation. Okay, as the hours are up, the grade point average is down. Okay, shoe size and colors in the rainbow, no correlation. You can kind of click through all of these and get some ideas for your examples. Okay, if you want an example of a scatter plot, you could say, well, I took a survey asking people to pick a color in the rainbow and what their shoe size was, and I plotted all of the points, and that would be this graph over here with the red dots, colors in a rainbow and shoe size. And there is obviously no correlation. There's no association or relationship between the data sets. Okay, that could be a scatter plot. You have an X and a Y axis and you have points plotted on that coordinate plane. Okay, it's data that can be analyzed. Okay, and then for number 2, it says data, and I'm going to kind of show you something here. I'm going to go to the data slide in your resource. Okay, these are called Frayer models. It's just, you've got a definition up top down here, and then sort of a description or some key ideas down here, and then a non-example on the right. Okay, 3y equals 24. That's not an example of data. That's nothing that is measurable. We can't analyze that. It's not a description. It's not an observation. But over here we've got some examples. Okay, it says it has units. That would be an example. It can be measured and numerically compared. Those are usually examples of data or data. Okay, age 14 years. That's a piece of data. Weight 105 pounds. Time 2 hours. Okay, color green. Color yellow, volume 47 cubic centimeters. Those are all bits of data. They're measurements, they're observations. And so we go back over here and you'll notice that I have data is a collection of facts such as numbers, words, measurements, observations, or even descriptions of things. Okay. That's exactly what it says on that Freyr model on the right. And then my example explanation, I typed in, data can be about anything. You could collect information about the eye color of everyone you know. You could then compare your data. I'm going to change that. You could then compare your data to national or international averages and make a hypothesis about the reason. And make a hypothesis about the reason. Okay, and that's what data is. Okay, put it in your terms. Over here it says in a scatter plot, a data point is plotted on the graph for each single fact, such as 500 miles, 30 miles per gallon. Okay, so if we look at this graph on the right, I'm going to go, let me see here. I'm going to look at this in big. Okay, it says in a scatter plotted data point is plotted on the graph for each single fact. Gas mileage, miles per gallon, is down here on the x-axis, and the distance traveled, okay, the dependent variable, is up here on the y-axis. So 500 miles, 30 gallons, that's one data point right there. Okay, there's another data point over here at about 26 miles per gallon and probably about 340 miles approximately. Okay, and that's data or data. And then you're going to move on to the next term, okay? And it's a cluster. It's a set of points or data that is gathered around one particular value. And if you look on the left, there's an example, okay? You can blow that thing up, right? And let's see here. You can look at that. Okay, there's a little cluster there. And basically these clusters, they tell us something, okay? Most of the samples are gathered in between about 10,000 meters elevation and about 22,000 meters, okay? So there are far fewer in between 0 and 10,000 meters. Okay, most of them are clustered inside there. And then if you look at that again, there's even, you could say, well, there's a cluster right here, and then there's a little bit looser cluster over here. Okay, there's a cluster in between 15,000 and 20,000 where they're looser. Okay, the cluster isn't as tight. The average annual temperature, right? There's more variation. There's more variation. There are points way up high and way down low. Okay, and that's probably because those really high peaks, some of them are near the equator and some of them are in far northern latitudes where it's much colder. Okay, these in between the 10 and 15,000 zone, they are just more moderate. They're more similar. For some reason, it's not as extreme at that elevation. Anyway, those are clusters, okay? And that's an example of what I'm asking you to do here today. So I just want you to finish up with the definition and an example or an explanation of a cluster and correlation. And then the last one is going to be line of best fit, okay? I want you to read through these slides. This shouldn't take you a terribly long time, maybe 25 or 30 minutes. And then what I want you to do is go back into the classroom here. Okay, and I want you to go to this exit ticket, which is basically asking you all the same stuff. There's going to be an exit ticket right here. It says scatter plot vocabulary. Okay, there are questions about each of those terms, and that's it. And that's your assignment for the day. If you have any questions, I'll be in a Zoom meeting at 2:30. It's posted in your class stream this morning with your assignments. I hope you are all well. I miss you, and look forward to seeing you in the next Zoom meeting. Adios.